And here are some worked out examples of writing domain and range. Again, we're looking for those math rules sometimes in the function over here, but usually the graph is the best way to determine the domain and range. So I'm going to use my scanner again. Here's my domain scanner because it's vertical. It's dealing with the x values that would produce a y value. So right now I'm going to scan left to right, and it's going to beep if it's producing an output. So in this case, with the quadratic here, a parabola, it would go beep, 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 all the way, because over here, there's a y value. Now it's really high up there, but this graph keeps going up, and it gets wider and wider and wider. And what we say for quadratics, it's kind of an automatic. The domain is all real numbers. Every x value is going to produce a y value. There's no x that's going to break some math rule. So then we go for our range. Now if I scan bottom to top, it's not hitting the graph, so it would not be beeping. So eventually, it does hit here, beep, 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 forever up. So I got to find out what that value is. Now there could be some clues in the function, or at this point, sometimes just using your calculator, that min feature on your calculator will get you there as well. So I know that this minimum right here is at 4 comma negative 6. So I only need that y value because the y value is the lowest at negative 6, and then all the y's above it work. So y is greater than or equal to negative 6. Sometimes the book might write it, or your teacher might write it for all real numbers. If you haven't seen that symbol before, to say, well, x is less than positive infinity and it's greater than negative infinity, that works as well. It means the same thing. So this one's called a cubic. We have an x cubed, and if I scan left to right again, it would beep the whole time. Beep, 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 beep. It's hitting the graph everywhere. Now it's hard to see, but like if x is 4, this graph's going to keep going down forever, but it's still going to widen. Again, we can confirm that there's no x value that's really going to mess this up or produce an error or does not exist or something like that in a cubic. So in this case, the domain is all real numbers. If I scan from bottom to top, it would just go beep, 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 beep. This graph goes infinitely up and infinitely down forever. So that all the y values will be covered. So the range for this one is all real numbers as well. Okay, we have an absolute value graph. We've got a negative, so it's flipped, so it's more of a peak like a mountain. It's moved over a little bit, moved up a little bit. But if I scan left to right, notice that it kind of looks like a quadratic that's just straight, but I can always take the absolute value of any number, just makes it positive, so it will hit the graph left to right forever. So that stays as all real numbers. And then if I scan bottom to top with the absolute value, I'm hitting the graph. If I went infinitely left or right, I'm hitting the graph, beep, 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 and then it would stop at this peak, at this maximum. Now this maximum is at negative 4, comma 3. So the highest y value, all the y's are lower than 3. So we'd say the y's are less than or equal to 3. Oh, I might have said negative 3, sorry about that. But positive 3, they're all below 3. This is one of the tougher ones. We have a parabola or an inverse graph here. I'm taking 5 divided by x minus 2. So if I scan left to right, it's hitting the graph. That red graph will go left forever, go right forever. So it's going beep, 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 beep. But there's that little break right there. We learned that this is called an asymptote. It's a kind of this invisible line that the graph tends towards, but it never actually has that output. I'm going to go quickly through the reason why. If you look, this looks like it's hitting at 0, 1, 2. So an x of 2. But if I look over my function, look what happens when x is 2. I get 2 minus 2, which is 5 divided by 0. That's one of those math rules that we said we're going to watch out for to say that's not going to make an output. So all the values work. In my domain, all real numbers work, but there's one value, there's one x value that doesn't produce an output. So I say x can't equal 2. I'm going to take that out of my domain. It's just like if it were a bag of all these numbers. Put all the numbers in that produce an output. X does not equal 2. It can't equal 2. It won't produce an output. Now I'm going to do something similar for the range here. I'm going to go bottom to top still. But it's hitting the graph, it's hitting the graph. Beep, 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 beep. So there, again, there's a little break there. So it looks like this graph tends towards 0 this way, it tends towards 0 this way, it gets closer and closer and closer to that x-axis, but it never really becomes that. Now there's a different reason other than we get an error. Like I can actually plug in 0 to this one just fine. But think about this. 5 divided by something. If I have 5 divided by something and I plug in numbers here other than 0, like I plug in 1 or 2 or 3 or 4, if I get bigger and bigger and bigger, this fraction just gets smaller and smaller and smaller. But if you think about this longer, 5 divided by some number is always going to have an output that's not 0. Like there's no number I can put in for x here that when I take 5 divided by it will ever output 0. Even if I put 0, negative numbers, positive. So there's a horizontal asymptote at y equals 0. Like this graph will never have an output of 0. So the range, all of them work. Graphs up here, graphs down here, all those y values are covered, but the only one that doesn't work is 0. So we take that out of our domain. And lastly, we have our square root function. And a scan left to right, doesn't beep, 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 and then it goes off into infinity. Now that x value right there is 1.5, comma 2. So I just need the x value right now. It started beeping at 1.5. So I'd say x is greater than or equal to 1.5. Lastly, my range says y values bottom to top, doesn't beep, 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 beep. As soon as it hits the graph, it starts scanning, beeping, where my y would be greater than or equal to 2. So I hope this is a couple good examples. Like I said, different functions. We find patterns in what their domains and ranges are, and it comes with practice. But hopefully this clears up using those scanners.